Hello everyone, my name is Tushar Rana and I am from IIIT Sricity and I am a second year undergraduate student doing BTech from CSE. So today's chapter is that organic compounds from halogens, that is alkyl halides and aryl halides. Okay, so this is an organic chemistry chapter. Okay, let's name the heading here. Generally the name of this chapter is alkyl halide and aryl halides. Okay, we will discuss all this. We will discuss that is first one is alkyl halides and second one is aryl halides. Okay, so it is an important chapter with respect to the JEE-Main examination. Okay, so let's get started. So, what in your mind comes when I said alkyl halides? Okay, so you all know what is alkyl means and what are halides also. Okay, if we divide it into two parts, that is alkyl group, you know, are okay and bonded with some compound. It is a um, simple chain like CH3, CH2 like that, or some branched CH2, CH3 like that, bonded with some X. This is generally our alkyl halides. Now, what about aryl halides? We will talk it about later in the second part. Okay, second part means in the second half of this lecture. So, coming on to the alkyl halides means any organic compound, any carbon chain which is connected to the halogen. Like halogen, we have fluorine. Okay, let me install my drawer here. Fluorine, chlorine, bromine, iodine. Okay, so if it is connected to the R chain, then it is called as an alkyl halide. So we will discuss some of the properties of this alkyl halides, some of the chemical properties, how this alkyl halides are made. Okay, some named reactions we will also see here. Okay, let's see. Classification of alkyl halides according to the class of carbon that the halogen is attached to. Okay, I'm telling you that if it is connected to the single chain like this, it can be connected to this 2-degree carbon. It can be connected to like this X, 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 C, C, C. So it is a 3-degree carbon. So it is saying just like that. If we have an alkyl group, it can be connected in only these three ways. None other than that is possible. Okay, so naming alkyl halides. Now, what about naming of alkyl halides? We can generally say that if it is a CH3 and X, what can it be called? This is what our methyl group, and this is alkyl halide. Any halide, okay. So methyl halide we can call. Now, there is a proper naming convention for this alkyl halides. First, select the longest chain. It is a rule of IUPAC, you know. Name its parent chain, okay. Contains double or triple bond if present, okay. Number from and nearest and substitute. Okay, these all are related to IUPAC naming convention. So you all know what is that. Okay, so like for we have the example. This is one CH3, CH3, CH3. It is a long chain, and the some branched also, and bromine is connected to the fifth carbon. Okay, so it is clearly from here visible that the fifth will be bromo, as it will be a prefix. So this here 5 bromo, and it is a 7 carbon long chain, so it will be hept, and no double bond, triple bond, so heptene. And at 2 position there is a methyl, and at 4 position there is methyl, so 2,4 dimethyl heptane. This is the naming convention. Okay, now if the bromine here, so another name 2 bromo 4,5 dimethyl heptane. So like this you have to name the alkyl halides considering the IUPAC naming convention. Okay, what is the structure of alkyl halides? Coming on to the structural part of the alkyl halides, CX bond is longer as you go down the periodic table. Okay, CX bond is weaker as you go down the periodic table. Okay, some trends are given related to the carbon, and that is R group and that X, because the R's last group which is connected to this halide will be carbon only. So we are talking about CX bond length here. So if we go down the periodic table, okay, you know what is the periodic table, how periodic table look like. Okay, if you go down a group in a periodic table, the CX bond is longer. Okay, if we go CX bond is weaker as you go down the periodic table. Okay, CX bond is polarized with the partial positive charge on the carbon, and okay, so both can be there. Okay, it is longer and weaker. As you know that if we have a single bond, then it is its strength is less than double bond. But if you talk about length, its length will be greater than this bond. Okay, so you know what is this and how it comes. Now, this also contains, the CX bond also contains some polarization on their both ends. Okay, I will zoom it here somewhat, given some data about that. You can check it out. Like, see, if we have a halomethane, single CH3 group connected with the different X element, okay, their bond length is given. See, as we go down the group, bond length increases, but the bond strength, see, decreases. Okay, decreases, increases. Okay, here also decreases. Dipole moment, you can see almost variable. Okay, variable, like that you can see. Let me zoom in first. Okay, now we have talked about the structure and some intro part of this alkyl halide. Now let's move on to the preparation part of this alkyl halide. Okay, preparation of alkyl halide. So how there are certain methods through which we can prepare our alkyl halides. First one is alkyl halides from alkanes. Okay, we mark it as the first one. So if we have alkanes, so no double bond, no lone pair, so we'll do radical halogenation. That is, okay, alkane plus Cl2 or Br2. Okay, this is the reacted compound. We are passing heat or light as a intermediate. So CH bond will be uh, CH bond will be replaced with CX bond, but gives mixture. Okay, so it is a simple rough idea how the bonds are formed and how that halogenation are done here. Okay, it is hard to control because excessive heat, then there may be a radical formation. Okay, via free radical mechanism, yes, true, because if there will be radical form, then it will contain radical mechanism, that is initiation. Okay, and that or propagation. Okay, it is usually not a good idea to plan a synthesis that uses the metal. Okay, see, if we have a compound CH4, if we need to add Cl2 as a halide to this group, so if you pass the heat H nu for making the radical, then Cl2 will be formed into some radical part. Okay, and this Cl will be broken down into radical. Okay, now this hydrogen H will combine with one Cl, and one Cl will combine with like this CH3, one H is here, and this is Cl molecule. It will broke like this, it will broke like this Cl will connect to this, and this H will connect to this. Okay, so we will get to structure. This one is this one is this. Okay, now again we will pass Cl2 here also, CH3 Cl2, and this, and we will get CCl4. This is the last formation of that alkyl halide structure. Okay, so we can form max number of alkyl halide from a molecule if we have the hydrogen part or some other part which can be replaced by that halide part. Okay, now second method, preparing alkyl halides from the alkene. Okay, here we can break the bond and put or we can get saturation by breaking the unsaturated bond. Okay, now alkyl halide from addition of HCl, HBr, HI to alkenes give Markovnikov product. Okay, you know about what is Markovnikov in second one. Okay, let me write here first. Markovnikov and anti. Okay, you know what is Markovnikov and what is anti-Markovnikov. In Markovnikov, we insert that Cl2 with the direct substitution, and it is opposite. Okay, so what is that? See, okay, let me zoom in first. See here, if we have this 2-methyl propene structure giving double bond between this bond, so if Cl comes here from this with Cl, okay, so where this Cl will come? Will this come here or will this come here? So what is Markovnikov? Markovnikov says that the stability, more stable side, it should come, and the other one said anti-Markovnik, it is just opposite. Okay, let's see. There will be two formation. Okay, this is one, this is two. Okay, this one is Markovnikov, and this is anti. Okay, so see how this structure comes. If this bond comes here, okay, this bond comes here, then the positive charge will become here. Okay, see, this positive charge comes here, and this double bond comes here. Okay, now, but to replace this positive charge, we will add that Cl2 that was we have to add it. So this Cl comes here, and it is a 3 degree carbon alkyl halide. Okay, see 3 degree carbon alkyl halide. Now, if you talk about like this, okay, if this double bond comes here, then the carbon positive charge will come to the endmost carbon. Okay, so here hydrogen will be here only. Okay, now if we connect this Cl minus and Cl comes here, so we have 1 degree alkyl halide. Okay, now you note that if we talk about stability of carbocation, we are talking about carbocation stability. So 3 degree carbocation is almost is greater stable than the 1 degree carbocation. Okay, so we will have that Marconic of product, that is this one and not this one. Okay, so only one stable product will be formed. Okay, now we have seen two methods. Now one more method is to make the alkyl halide. We'll see from that alcohols. Okay, so alcohols can only be used, can also be used to make the alkyl halide products. First, see reaction of tertiary carbon okay, carbon alcohol with HX is fast and effective. Okay, I told you that if 3 degree carbocation will be formed, it will be more stable and it will form the alkyl halide more effective and fastly. For example, if we have this 3 degree carbocation, okay, and we have a X bond to be here, to be transferred to here. So this OH bond will be broken and this 3 degree carbocation will be formed. Okay. Now this will be more very much stable. So X will come here and this will be the product. Okay. So here we can form 3 degree, but see, I told you this one. Okay. Primary, tertiary, secondary, 3 degree, 2 degree, 1 degree, and this is single OH CS3. Okay. Now, if it okay, this is some cyclic structure. Okay, CS3 connected to this is also 3 degree. Okay, now when this 3 degree will come here, this Cl will come here because this OH will be goes out of that. And but here we use HCl as a gas. Okay, okay. Some of the intermediate we have to pass to increase the reactivity. And as we go increasing the number of carbocation, number of carbons, the reactivity also increases with that HCl or any halogen gas. Okay. Now, primary and secondary alcohols reacts very slowly, often rearranged. Okay. So we alternate use SOCl2 or PBr3. Okay. So as you seen here, tertiary can react very fast. Okay. But the primary and tertiary, okay, the primary and secondary alcohol, this is a type of alcohol. Okay. So primary and secondary alcohol does not react that much fast. So we use some of the reagent, some of the intermediate there. So for chlorine, we can use SOCl2 with pyridine and PBr3 with ether. Okay, so it will give a faster reaction as compared to the single one. So this is a 2 degree carbon. This is a 1 degree carbon. Okay, sorry, this is also 2 degree carbon. Okay, so now for removing that, okay, we are using chlorine here. No, this will also form. This will be also formed. So you have to notice that what is the byproduct also formed. So you have to make sure about that also. So these are the product. So you can check it out. Now, okay, one more method is there. That is preparation of alkyl halides from the alcohols and hydrogen halides. Okay, we are preparing the alkyl halides from the hydrogen halides. See, ROH plus HX, simple HX and ROH giving you RX plus H2O. Okay, so here also some reactivity comes here. HI is most reactive, it is most reactive, and HF is the least reactive. Okay, it is HBr and reactivity PT decreases. Okay, now if we talk about alcohol reactivity also, as we go down the number of carbon atoms connected to that alcohol part, reactivity decreases. Okay, so both of them reactivity, both of the scenario we have the decrease in reactivity. Okay, now these are all the methods through which we can form our alkyl halide. Now let's see some of the properties. Okay, some properties of this alkyl halides are, see, alkyl halides are weak polar molecules. Okay, true. Okay, they exhibit dipole interaction between, as there is a halogen and there is a higher and lower negative electronegative difference. So there comes a dipole moment and also a polarization property. Okay, you all know what I mean to say, like this. as chlorine is the most chlorine, more electronegative atom. So here delta negative and here delta positive, and these are the dipole interaction. You can see that. Now, if we talk about boiling point and melting point, so here we have given some of the boiling point examples. Alkylates have higher boiling point and melting point than alkanes, okay, having the same number of carbons. Boiling point and melting point increases as the size of R increases. See, here will be melting point low, it will be greater than. Boiling point and melting point increase as the size increases. So here we are increases, so here boiling point also increases. Now, if we talk about solubility, Rx is soluble in organic solvent. Rx is insoluble in water. Okay, Rx not soluble in water. You need to know that only. Now, talking about some of the chemical reactions. Chemical reactions. Now, there will be some certain chemical properties of this alkyl halides also. Now, we have the alkyl halide formed. Now, you all know what is nucleophile. Okay, nucleophile are basically bases. Okay, so if we have a nucleophile, so this nucleophile will detach this X and will connect to this R. Okay, so there will be a substitution reaction going on. So this nucleophile, which is containing some lone pair, it will go like this one, and this will go like this one. So R, Nu, and X negative will be formed. So alkyl halide undergo substitution reaction with nucleophile. Now, alkyl halide also undergoes elimination reaction with Bronsted-Lowry bases. Okay, like if we have a given basis, okay, and we have connected H and X. Okay, now there will be elimination here. How the elimination will occur here? See, this hydrogen, okay, see, this hydrogen will come here, okay, and this base will be connected with this hydrogen. So due to that, that hydrogen double bond will come here and X will come here. So X negative will be formed here, HB positive, and a new alkene structure will be formed here. Okay, so you know in the organic compound, organic chemistry, that for the preparation of alkene, how the alkene are prepared. So we use bases there. Okay, so that time dehalogenation, basically that reaction is called. Now, general features of nucleophilic substitution. There may be many types of SN2, SN1, SNI. There are three types of basically substitution reactions. We talk about SN2 first. Okay. See, sp3 hybridized carbon atom nucleophile. Okay, you know, I told you in the previous slide only. So if CH3Cl and OH is a nucleophile, it will come to this one, and OH will be connected to this, and Cl will be the leaving group. Okay, so you need to note this two major point, nucleophile and the leaving group. Talking about iodine, iodine reacts with this SH nucleophile. It will also undergo same reaction, but with Br, see here will come a new changes. A new carbon nucleophile bond forms. The leaving group comes off. Okay, so similar all this. Just we need a nucleophile containing some lone pair group or some electron density groups. Okay, now mechanism of nucleophilic substitution. There is a RX bond which connected to this nucleophile, and this is the structure of nucleophilic substitution. But how the substitution occurs? See, but what if the order of bond mixing and bond breaking? Okay, there are three possibilities. Bond making and bond breaking occur at the same time. Okay, when the nucleophile comes and when the leaving group leaves that carbon atom, carbon compound or alkyl halide compound, the both of the bond formation and bond brokening or bond leaving occurs at the same time. Okay, so it is a one-step mechanism. So that's why it is called as a SN2 reaction, and the rate equation is second order reaction. Okay, it can be asked in the question 2 also. So this is the chemical or mathematical part. Now, the mechanism of an SN2 reaction. Okay, we have a SN2 reaction. This is CH3CO negative, one-step reaction. Here the leaving group leaves. This this nucleophile comes and this Br leaves. And this product is formed, and Br is the leaving group. Okay. Similarly, if we talk about SN1 reaction, it will have a carbocation stability issue. Okay, so just we need to check that one only. Like if this Br leaves, then here first carbocation will be formed. Here bond breaking and bond leaving will not occur at the same step. First the carbocation will be formed. Now we will check the carbocation stability, and the most stable carbocation position will be the position will be the our destination for this living group. Okay, so let's see. Heterolysis of CBr bond. Okay, intermediate step. This is one. Now, after that, there is a nucleophile attack. So where this nucleophile will attack? If we have this OH group, okay. If we have like this one, CH3 positive, and this is connected to CH3, and this is CH3. So this carbocation will jump to this one only by exchanging their hydrogen, and here Br will be attached. But we have here 3-degree carbocation, so it is more stable. So we will attach this nucleophile to this one only. Okay, so this will be our the product. Okay, so like this you can see. Okay, here is some transition state of SN2, and this is SN1 reactions. Okay, a better living group is more able. So both of this reaction requires a better living group, and the living group and stability, or we can say the increasing living group ability is Ri is the most and Rf is the least for both SN2 and SN1 reaction. Okay, now let's take a new page where we can talk about our second part of this chapter, that is aryl halide. Aryl halide. So what are aryl halides? See, we talk about alkyl halides that are simple chain structure or chain compound of carbon. But in alkyl halides, okay, in alkyl halides, we will discuss about the formation of compounds with halogens containing the ring structure. Okay, it can be benzene, okay, or any aromatic compound. So here comes X like that. Okay, so we will talk about like that. Now, what are aryl halides? Aryl halides are organic compounds containing halogen attached to an aromatic ring. Okay, this is the main funda of this alkyl halide. Okay, let's take a new halide. Okay, all are waste. Red one will be okay. Okay, an aromatic ring. Okay, halogen attached to an aromatic ring. This you need to focus on that part. They have the general formula of ARX, true, where AR is the phenyl, okay, or substitute phenyl, and X is fluorine or chlorine and bromine. So we have given some of the example here also. See, this is chlorine, this is bromine, this is iodine, and this is chlorine. And both of the, and this whole part is R, this part, okay, this part, this is all our aromatic part, and this is part of X. Okay, so some of the naming convention is given here. Chlorobenzene, this is meta, as you know that this is para, meta. Okay, so just like that. P iodophenol, ortho also, sorry, orthoparameta, orthochlorobenzoic acid, all these parts. So different connectivity to different position gives you different naming convention of the compounds. Now, let's see some of the structures. An aryl halide is not just an halogen compound containing an aromatic ring. Benzyl chloride, for example, is not an aryl halide. Okay, this compound is not an aryl halide. Why it is not an aryl halide? See, its halogen is not connected directly to the aromatic ring. It is connected to this R part. So this is a alkyl halide. Okay, this one is RCl, RX. So it is an alkyl halide. Okay, how it comes? If this Cl was attached to like if there was not double bond, like this Cl was connected here, then it could be have a alkyl aryl halide. Okay, but it is a aryl halide. So it is a simple RX bond. So it is a alkyl halide. Now we will see some of the preparation methods. Preparation of aryl halide. So similar to that one, but here we have different compounds, different reagents, and different intermediate steps. Okay. So talking about preparation of aryl halide compounds, we have the first one, that is direct halogenation of aromatic compounds. So it is generally can be viewed from the name only. We will give a direct halogenation of this aromatic compounds to that halogen which we want to attach to that aromatic compound, like which, for example, we have any aromatic compound containing aromatic AR and H, which is to be replaced for inserting that X. Okay, so the basic funda is Like if ARX bond is there, so this bond will be formed. H will be connected to one X element and one X element will be connected to the AR. Okay. And we have here Lewis acid as our intermediate. Okay. So ARX and HX. So it will be contributing to or initiating the reaction fastly. Okay. So X can be Cl2 or Br2, not I2, not fluorine. Okay. I and fluorine cannot be here. But why? See, we are using fluorine. Okay. Sorry, some of the Lewis acid which we are using are FeCl3, AlCl3, BeF3. Okay, why fluorine? Fluorine is a very much lower, very much smaller size, smaller in size, so it will not fit into this aromatic compounds. Okay, now if you want to make the compound of, if you want to make this compound by this process, that is direct halogenation, we will check also this NO2 group. Okay, NO2 that is electron donating or electron withdrawing group. Depending upon this, we will ensure where this chlorine will be attached. Okay, so for here the chlorine is attached to this ortho, this is para, meta, and this is para. So here at meta position the chlorine is attached. Now some more reactions are there. From aryl diazonium salt, we can also make this aryl halide. Like we have aryl N2 positive, so N2 will be our leaving group, leaving group. Okay, and BF4 negative is our ion, so AR will be connected with this BR BF4 F fluorine. For this CuCl, ArCl, CuBr, ArBr. This aromatic compound can be any ring compound, and this bromine is connected to that ring only, not any other biparts. Okay, this Ki, that is ARI, and we will release this N2, which is the leaving group. Okay, so it is also known as diazonium salt step. Okay, how we can it can be said that which organic reaction result in the formation of aryl halide and the release of N2 gas. So their diazonium salt reaction comes into place. Now, one more preparation step, that is Sandmeyer reaction. Let's say this one. What is Sandmeyer reaction? This is a named reaction first one. Named reaction. Okay, named reaction means that it is a popular reaction. It can be asked like in the question generally that explain the Sandmeyer reaction or identify which of the reaction is the Sandmeyer reaction. So here also diazonium group comes in the picture. So replacement of this diazonium group by chlorine or bromine is carried out by mixing of the solution of the freshly prepared diazonium salt, this one, with the cuprous chloride. Here we take the reagent cuprous chloride. Okay, not any other reagent, just only Cu. And this X can be chlorine or bromine. Okay, so or cuprous bromide at temperature, at room temperature. So if it comes in question like this, AR N2 positive, X negative, X or X negative. Okay, and you have the given reagent as Cu. We can take CuF. Okay, and ArF plus N2. So this reaction will not be proceeded. It will not be done. Okay, so just you need to make sure this one also. Now let's see the preparation. Okay, some of the summary part of that preparation. The preparation of aryl halides from diazonium salt is more important and direct than direct halogenation for several reasons. Okay, you need to know that. First one is fluorides and iodides, which can seldom be prepared by the direct halogenation. Okay, see, I have told in that which one reaction, this is Sandwich reaction. It is a type part of diazonium salt reaction only. But see, here in diazonium reactions, what you are seeing, that fluorides and iodides cannot be prepared by direct halogenation. Okay, which can sorry, this fluoride and iodide we can prepare it by the halogenation process, but with the diazonium salt preparation we can't prepare that AR F or AR I, just like this one. This is the example. Okay, now second one, where direct halogenation yields a mixture of ortho and para isomers. The ortho isomer at least is difficult to obtain pure. Okay, on the other hand, ortho and para isomers of corresponding nitro compounds, that is NO2, that is our electron donating group, from which the diazonium salt ultimately comes and can be separated by fractional distillation. Okay, so in the diazonium salt method of preparation of alkyl halides, we can separate the NO2 compound with the fractional distillation process. Okay, So we can get the meta product, sorry, the ortho product, which is at a pure state. Now, let's talk about some of the physical properties related to aryl halide. Okay, physical properties of aryl halides. See, as these compounds will be readily available in the to us when they are formed. Okay, so we can check what are the chemical properties or what are the physical properties about that. Okay, so aryl halides are insoluble in water but soluble in organic solvent. Okay, talking about that alkyl halide also that were insoluble in water but soluble in organic solvents. Kyle and aryl shows this first one property. Okay, now para isomer has a melting point about 70 to 100 degrees Celsius. That para, okay, what can I say like this one? If we have a compound and we need to connect this X and it is forming like that one. Okay, this one is the X. So this is the para product. Okay, so it will have a melting point about 70 to 100 degrees Celsius. Para isomer is more symmetrical, which fits better into crystalline structure, and the see it is a more symmetrical. Because of the strong in crystalline forces, para-isomer is less soluble in given solvent than the orthoisomer. Okay, so as you know that this aryl halide is insoluble in water, but if we talk about solubility in organic solvent also, so as compared to the ortho product like this one, okay, we have compound like this. This one is ortho X, and this one is a para. So this is ortho, and this one is para. If we talk about solubility, okay, solubility, we mark it as a and this is a B. So the solubility will be A will be, see here it is written, because of the strong in crystalline forces, para-isomer is the less soluble. Okay, so this ortho solubility will be greater than as compared to B. Okay, but if we talk about the melting point, it will be less with compared to this one. Okay, so it is quite relatable to this one also. If it has a melting point is higher, so solubility will be also lower. Okay, now there are some chemical reaction given for this one. This one is bromine with alcoholic AgNO3 giving you no reaction. If you have a alkene AgNO3, no reaction. Okay, so the vinyl halides and aryl halides are very low reactive. We will see the reason why these are not reacting. Okay, for this example, we have aryl halide, this is vinyl halide, that one only. Okay, with Ag plus no reaction, OH negative, OR negative, NH3 negative, CN negative, AR, LC. These all are or nucleophile. Okay, so it is giving no reaction. Okay, so we have the reason also. The low reactivity attributed due to two factors. First, delocalization of electrons by resonance. Okay, see here, if you remove this chlorine atom, okay, by taking out this double bond atom, so we will get different resonating structure. We will not get the, see here, positive charge comes on this chlorine and negative charge comes on this carbon. Okay, so it is not a not we what we can say stable structures formed. Okay, so delocalization of electrons by the electrons, first one. Second one, difference in sigma bond energy due to difference in hybridization of carbon. Okay, this is the second reason. So that's why there is the low reactivity, and that's why there will be no reactions formed, no product formed when reacting aryl halide or vinyl halide with this product, like with this compound like Ag positive, OH negative, OR negative. Okay, so these are the some of the reasons. Now, talking about chemical properties. Chemical properties. Okay, so what are the chemical properties related to the aryl halide? First one is the Grignard region. You all know what are Grignard region. Okay, so if we have a alkyl aryl halide and we have Mg as an compound, so it will connect to this one only and will give a Grignard region. This is a famous Grignard region, MgBr, MgCl. Okay, THF is our region here. Now we have a bromine here, and G is a that group. Okay, so G can be R, OR, AR, Cl. Okay, G can be COH, OH, NH2, SO3, CO2, COR, CN, NO2, and many others. These are the different compounds which can be formed to this one after making the Grignard reagent. Okay, so Grignard reagent also shows different reactions with different reactant. Okay, so let's see some of the electrophilic aromatic substitution is also given. So when reacting alkyl halide, aryl halide with HNO3 H2SO4, we will give NO2 and this one NO2, H2SO4 and SO3. SO3 is here, SO3 is here. What is it is trying to say? Just ortho, para. This product is formed. Okay. Meta will be not formed. Okay. See, it is a strong nucleophile, so it will form ortho and para only. Ortho, para, ortho, para. Okay. This CH3, CH2Br. Okay. This is RX. This is direct halogenation. And we are using Lewis acid there. Now, nucleophilic aromatic substitution. Just as similar to that alkyl halide. Here ARX, and this is the nucleophile compound. It is connected to this, and X is taken out here as a living group. So here electron withdrawing group favors the uh, nucleophilic substitution reaction to the ortho and para position. See, if chlorine is reactive with NOH containing OH minus as a group, okay. See, so with the direct, it will give no reaction. But if we increase the temperature, so it will give O negative Na positive, okay. And on hydrogenation, it will give OH. Similar to if we increase the temperature if we decrease the temperature, but we have electron donating group, and it is written that if electron donating group is at ortho or para position, the temperature we will require will be lesser than the previous one, and we can get the reactions. Okay, so O negative Na positive. If we have a if we have a two electron donating group, so we will require more lesser temperature. See, 160, it is decreased to 130 degrees, and just we are boiling here NO2CO3. So we will get alcohol product here. Okay. Now, if we have a 3 NO2, okay, 1, 2, 3, just we need to little warm, just a smaller heat, and we will get the product. So as we increase the temperature, the formation of that alcohol from that aryl halide will be increasingly. Now, analysis of headlights. Okay, it is a summary part. Let me see if anything else. Okay, nothing. Insoluble in cold sulfuric acid. Okay, some of the properties you need to learn. Inertness towards bromine and carbon tetrachloride, CCl4, and towards permanganate solution. Okay. Formation of orange to red colors when treated with chloroform and ammonium chloride. These are some color changes properties. Dissolution in cold fuming sulfuric acid, but at slower rate than the benzene. Okay, these are the some points you need to learn. Just learn. We have no logic behind this one. Okay, so we have covered almost all the parts related to the aromatic and that is aryl halide, alkyl halide, chemical reaction properties, preparation. Okay, now let's move on to the some question parts. So I have taken out some PYQ slides only. So let's see. Okay, let me take a new page. Okay, previous year question. So better to solve the previous year question which were asked and generally solving simpler questions. Let's move on to the question part. Okay. So question number one. Question number one. Okay, let me decrease the intensity. Which of the following compounds will show retention in the configuration on nucleophilic substitution? Okay, so see, this is our nucleophilic group. Okay, nucleophile. So if nucleophile will come to here only, why? Because this PR is a living group. Okay, so it is asking about stereochemistry. Stereochemistry means if this chlorine will come at a edge or dash. Okay, like that. See. Let me show the reaction first. Question number one, CH3, CH3, C6H5, and this is Br. Okay, so okay, so if this OH negative had to come here, okay, This OH negative had to come here. So this Br will be cutted here. This Br will be formed here. So what will be the product? It will be CH3, CH, okay, and this is C6H5 or anything, and this way there will come some Br, okay. Sorry, it will be OH. And now the B part, it will be okay. This one is a 1 degree carbon. Now, if it will come here only, it will also okay. First one, sorry. I mistook the question. Let me erase all the part. Okay, wait. Okay, okay. See, for this one, there is 3 carbon. Okay, 3 hydrogen and 1 Br. If we remove that one, so but this first one, there will be no reaction. So first one is the first one case is the deprecated. Now, if we talk about second one cases, okay, in this case it will give us 2 degree carbon, 2 degree carbon cation, so it will be less stable. But if you talk about this, here will be carbocation form, but we have the more stable carbocation stability formation. Okay, so this CH3 CH, this will come here positive, C2H5, and this CH2 will come here, and this OH negative will come here. Okay, so this will be 3 degree carbon and more stable. So it will show most retention in this nucleophilic substitution of OH negative. So this will be our answer. Okay, so you need to check the stability also, the stability of carbocation. Okay, now let's talk about question number second. So what question number second is saying? Question number second is saying, consider the reaction sequence, bromine OH negative H2O giving you OH plus Br. Okay, this is the rate. Okay, now second one OH negative C2H5OH. Okay, there is so these are the some of the reaction mechanism given here. Now we need to identify which statement is true. First one, changing the concentration of base will have no effect on reaction 2. Changing the concentration of base will have no effect on reaction 1. And what is that? Changing the base from OH negative to OR negative will have no effect on the reaction number 2. And doubling the concentration of base will double the rate of both the reactions. So see, first one, let's see one by one both the reaction. So for reaction number 1, we have rate constant is given as K times T minus Bu Br. Okay, this is T minus, no, this is T only, some product. Now for reaction 2, we have a rate equals to K times T Bu Br and OH negative. Okay, so see, reaction 1 is independent of OH minus concentration C. Okay, reaction 1 independent of OH minus concentration. Okay, there is no dependence of the concentration of OH minus in the reaction 1. Whereas in reaction number 2, we have a dependence on the concentration on 1. Okay, or we can say that reaction 2K depends on concentration of OH minus. So it will have an effect. So hence the changing the concentration of base will have no effect on reaction number 1. Okay, so there will be no effect on the reaction number 1. So this one is the B answer. Okay, now let's see question number 3. What question number 3 is saying? Question number 3. So according to question number 3, the major product obtained from E2 elimination of 3-bromo-2-fluoropentane. See, here we have to do E2 elimination. Okay, in the alkene chapter, you have heard about this term. See, so first make the structure which is given here. That is CH3, CH2, CH, CH, CH2. Okay. Sorry, this is CH3, and here we come PR. This is F. Okay. Now, if we have to do and the E2 elimination, then we will require some of the bases. Okay, some base which is given, and we have written the E2 elimination also. Okay, so it is also easy for us. Now, just we need to remove the halogen part, one of the halogen part. So which one will be go, bromine or fluorine? Okay, let's see this one. So if in accordance to that, fluorine and bromine, fluorine is a more electronegative atom, so it should go, but there comes a chance. Here the product will be formed like this: CH3, CH2, single bond, CH double bond, CF, and CH3. Okay, so why this? So that base abstracts most of the acidic hydrogen and departure of better leaving group takes place simultaneously. Okay, so the bromine will be the more possibly the leaving group. So this will be the structure formed. So what is the answer? So this one will be this. Which one? Okay, this is the structure, that is B. Now question number 4. What question number 4 is saying? The mechanism of SN1 reaction is given as, okay, Rx giving you some R positive and X negative ion pair, and when reacted with the solvent ion pair, it is giving you Ry plus X negative. Okay, a student writes general characteristics based on the given mechanism. First one, the reaction is favored by weak nucleophiles. R positive would be easily formed if the substance are bulky. The reaction is accompanied by racemization, and D is the reaction is favored by non-polar solvents. So we need to check which statement is correct. So see, first one, we have given the details regarding SN1 reactions. So SN1. So we need to write the properties according to us, and we will check with that. So what does the SN1 reaction mechanism done? So it is SN reaction is favored by polar solvent. First, this one is the point. Okay, plus solar solvents plus weak nucleophiles, and it also needed some bulky substances. Why bulky substances? Because if 3-degree carbon will be there, the stability will be higher and the SN1 reaction will be more preferable there. Okay, substituents, and the reaction is accompanied by racemization also. Okay, and also racemic mixture, that is stereochemistry. You have heard about this term in optical isomerism. Okay, so which one is that? This one is also correct. This one is also correct. This one is also correct. Okay, so A, B, and C is the correct statement. HD is, it is written reaction is favored by non-polar. It is not wrong. It is wrong. All three are true. Above. Now let's see the question number 5. What question number 5 is saying? The decreasing order of reactivity of the following compounds toward nucleophilic SN2 is, okay. So if you want to add some nucleophilic, okay, to this aryl halide compounds, this will be the reactivity will be highest and where will be the lowest. See, NO2 group present at ortho and para position. This ortho and this is para. Okay, so the compound which is containing ortho and para NO2 position, it deactivates the benzene ring and make the carbon attached to the ring more electrophilic. Okay, so for the incoming nucleophile which is given here or not given here, we will take just nucleophile if it is trying to attack here. So for incoming nucleophile to give SN2 reaction, as it is asked SN2 only, so the rate of SN2 reaction decreases as the hindrance increases. Okay, so the main funda is SN2 reaction decreases as hindrance increases. Okay, so according to that, I will write the stability order, sorry, okay, reactivity order, and we will check. So, okay, let's see. So first one will be CH2Cl, giving with this one. This is NO2 and this is NO2. See, this is a para and this is a meta, so there will be a more preference here. Now, this is a NO2 and this is NO2. Now here not both ortho and para comes, here one ortho comes, but para is not here, so we can active here nucleophile better than the next one. But if you talk about this one, okay, this is single NO2, NO2, okay, CH2Cl. So here no ortho and no para, so that's why it is the third one. And the last one will be simple one, that is CH2Cl. Okay, so the stability will be ordered like this. You can match the option according to that. Now let's move on to the next question. Question number 6. So what question number 6 is saying? The major product in the following reaction is okay. Let's do not see the option. Just try to solve by our own only. We have given this substance as this one and this one, and we have I as a halogen compound, and we have a T-butyl oxide, and we are giving a this. So it is a nucleophilic addition. Okay. Sorry. So what we have to do? See. For this nucleophilic addition, we just need to first leave this group. So on leaving this group, there will be a carbocation formation will be done here like this. This carbocation will be formed here only. Okay, but we will try to have a more positive hydrocarbon, more stable hydrocarbon. So this will be like this one, and here carbocation will be formed. Here hydrogen, here and here. So this will be our preferable carbocation. Okay, now we will see the hydrogen as a here, or maybe hydrogen from here can be come to here. But let's see, there will be two products, one, two, this one, and this one. Okay, like this one, and one can be like this one, this one, this one, this one, this one, and this one. Okay, so this two product can be formed. So which one is more stable? See here, one carbon chain, one carbon chain, one carbon chain. Here 1, 2, 3, 4 carbon chain. So this one is more stable. So this is our product. Okay, so let's see. Okay, this is C is the our answer. This is major, and the product can also be formed like this one, but this is our minor. Okay, these are just two products formed. Now let's try to solve one more question. That is question number 7. The decreasing order. Okay, this is also a question regarding the reactivity towards AgNO3 solution. Let's see. First, try to solve the first one, A part. If you have a given this tertiary molecule, okay, triangular shape structure that is connected with OMe, and we are passing AgNO3 solution. So it will give us structure of like this. This bond will come here as this Cl goes out of there, and this positive charge comes here. So to accommodate that, it can be formed the structure, and this OMe is here, OMe. Okay, so how the structure will form? This will give a structure like this one. Here will come a double bond. Here positive charge comes. Okay, or it can be connected like this one also. OMe is here only. Like this positive charge comes here. Okay, sorry, this double bond comes here. So this positive charge will be cancelled out. So this will be the R compound. This double bond comes here, and the positive charge comes here plus OM. So the main funda is to take the positive charge on this OMe part. Now, aromatic compound is well stabilized by the lone pair. How? Here, aromatic compound. Here, why I did all this? We can connect all in all the any of this step, but see, this is the lone pair. Okay, so here lone pair compound is stabilized by lone pair of OM. Okay, OM. See, so that's why the formation the reaction will occur here faster than the other one. So just this was the main funda behind that. So this will be the first one, that is A. A will be highest, so there are two options. Okay, and after that B, surely there will be B only. So A and B are the same. So B and C we need to check. Now talking about C and D. C. This is a 2-degree carbon, and uh, this is also a 2-degree carbon. But see, here is a NO2. This comes gives a minus I effect, and due to minus I effect, the carbocation stability decreases. Okay, so it will be last one. So the correct order is this C1. That is A greater than, B greater than, C greater than D. Due to minus I effect of NO2, carbocation stability decreases. Okay, but here 2-degree, here also 2-degree, both are 2-degree. Just after that, you need to check the electron donating or withdrawing group attached to that one or not. Okay, so that's all for now. We have done with the chapter. We have discussed all the important properties and preparation chemical reactions, and we have done some important question related to that also. So for now, I am continuing till that only, and you can try more and more question on this chapter and be more confident. Okay. Thank you all of you. Bye bye. We will meet in next lecture.